Yeah, we're live at 6:59. Hope everybody's happy out there. Apparently, I had people waiting for me. Awesome. I've already spilled my beverage here. Tonight, we're going to talk about some very cool stuff. First of all, if you take a look at the thumbnail of this video, you'll see that this crazy Honda intake manifold. This is what happens, I think, when you have too much time on your hand, or and this could be a really good thing, is that you have too many questions on your hand. So way back when I was racing the Del Sol and US touring car, and I was doing a lot of Bonneville stuff, and I was heavily involved in the B series things, and I was writing the book on Honda stuff. I did this intake manifold because something dawned on me when I was looking at the manifolds. And if you look at the firing order, I started kind of going down this firing order path, and I was thinking of the firing order, and is in the firing order of the Honda is 1342 are the adjacent cylinders like stealing airflow from one another. So I started thinking, okay, that definitely must be the case. So the way that I combat that in my mind, because as we all know that the Honda engineers, they're terrible at making products. The Honda stuff doesn't work. It doesn't last. It doesn't make lots of power. It doesn't do anything great, right? So I thought what I need to do is I need to make another manifold that's much better than what the stuff that Honda makes. Much better than the P30 Del Sol manifold or the Type R manifold, the factory Type R manifold. So what I did was I came up with the idea to do a dual plenum intake manifold on a 4-cylinder. The reason that I wanted to do that, besides it's a dual plenum, and you could tell people I have a dual plenum, and you have two throttle bodies, and you have 2 air intakes, so that you have an unrestricted airflow of, maximum airflow going to the motor. The other thing that I wanted to do is I wanted to isolate pairs of runners. So, and I was, not just because I thought that this was going to work, I wanted to test it to see if it did work. So I could isolate pairs of runners, and I could isolate the pairs that I thought would work and not have one cylinder, stealing from another and over scavenging from another one. I could test to see if that worked. And if that didn't work, I could try other things. I could try other pairings. That was a nice thing about this design, is it lend itself to me changing the positions of them and pairing different runners, which was kind of cool. So I wanted to do, and the dual plenum allowed me to isolate basically 2 cylinders in each one of the plenums, obviously thereby having even more airflow relative to the throttle body size in the plenum. And then the other thing I did is I made it so that I could join or not join the plenums. So I was doing, all kinds of in-depth craziness. And in all of this testing, and it was very, very cool, because I like doing this. I like figuring out what the test procedure needs to be and the test piece needs to be for me to figure out the things that I want to figure out. So once I do that and I'm able to get on the dyno and actually do the testing, then that's the exciting part, and we can make all this happen. And what I found out is that the guys from Honda, the guys that designed the factory B16A, the P30 intake manifold, and the Type R manifold, really have a very good grasp on what they're doing for that particular motor. That the manifolds that they made were actually fairly effective, much more so than my super cool dual plenum intake manifold, which didn't seem to want to do anything spectacular other than, we could potentially lose power. And I didn't really see anything significant from the pairing of the, because you get that a lot from the V8 guys. Oh, well, in the firing order of these 2 adjacent cylinders, one of them is drawing the airflow and it's getting all the good air, and then the one that's next in the firing order just gets a vacuum and so it's not breathing as well. And you get all of that stuff. And I've never seen anybody show me, really where that's happening or that's not happening, or it's absolutely happening. And on the B series, I kind of saw the same thing, that despite the fact that I wanted that to be something, that at least on the dyno, this showed me that it was not something, and it was not something that I needed to be concerned with, because I was already trying to figure out, okay, now I do that and I can mate it to twin turbos and, twin intercoolers, or at least twin in and twin out single intercooler. I had all of these grand ideas about making all of this stuff happen, but as it turned out, it was all for naught. But, they're not all home runs. Sometimes they're not at all. But that doesn't mean we stop testing. And that was a good test. Like I said, I was really excited about it when it first happened. And that's happened before. You know, you, like Edison said, that I didn't figure out how to invent the light bulb. But before I did that, I figured out thousands of ways not to do it. And you dismiss all of those. And this dual plenum is a perfect example of that. And I know that I could do a manifold that would improve power at some part or another. We know how to do that. But I was hoping to just be better everywhere and be awesome. And that's not what happened. So the other thing I want to talk about tonight is I want to talk about this. And you guys can kind of take a look at this. Hopefully you guys can see it. Yeah. Yeah, huh? Math. What's up? Very cool stuff. This is on the 4200. I also did one on the Honda B series. And what I'm doing, the video I'm working on right now that I'll load up right after I get off of here, is I'm comparing a turbocharged B16A that I ran to the turbocharged 4200 to figure out, no, not which one makes the most power, because actually in this case, the 4200 still made a little bit more power, but they both made over 500. So it wasn't to figure out which one makes the most power. It was to figure out which one is the most efficient. Which one likes being turbocharged the most. That's the way that I like to phrase it. And is one of them more receptive than others to that? So I showed you dyno results of both of these, which I've run before. But I also showed you the math that's associated with, that's right, math. That's what that board was. The math associated with figuring out how efficient these are. And then this is all math that you can take and use and plug in your own variables in there. And you could use that for any boosted motor to find out, okay, is it doing what it's supposed to? And it goes even beyond the Holdner power boost formula, because we cover, and this is one of the things I wanted to talk about tonight is horsepower per pound of boost. Is it really, an effective measurement? Does it tell you, or what does it tell you about your turbo application? Does it tell you that, it's effective, or what is it telling you? For me, I like to always know what the NA power output is. That way I know right off the bat, if I run boost and I know the NA power output, I know what it should be doing. The formula tells me that. If it doubles the power output at 14.7, I know I'm doing pretty well. But more than that, I'm not just interested in patting myself on the back for putting together a good turbo combination. What I want to find out is that if it's not doing that, it also tells you that, and then you should start looking for something. So for instance, you're not going to get to that. You're not going to equal that formula if you're running pump gas, for instance. If you're running it non-intercooled, you're not going to get there. If you're running a very restrictive exhaust, you're not going to get there. There are a lot of things that are going to stop you from making the kind of power that we show when we run stuff on the engine dyno in an optimized environment with good fuel and good intercooling and all that stuff. A lot of times you're not going to get that on the street, and you're never going to get that on pump gas. I mean, I've never seen it. Just because you can't run enough timing, you can't get close enough to the threshold with enough timing to make the kind of power that it requires to get these, to equal this kind of power output. One of the things that adds to that quite a bit, and I go over that in this video, is that if you run E85, also anything you do to cool the charge temperature, if you run cold water or run ice water, like in the previous video that I did, all of that stuff can allow you to basically enhance the boosted part of that formula, because you're artificially making the turbo motor better relative to the NA motor. And E85 is a perfect example. If I run E85 on an NA motor, not very often do I get gains. There have been some instances like with Coyotes where it does seem to be receptive to it, but nowhere near, I've never seen any NA motor get the kind of gains that you get on a boosted motor. Now, it may be that I need to run a 13 or 14 or 15 to 1 motor to really get what's possible out of it. But I know when we add E85 to a turbo motor, even before we change the timing or anything, if let's say we go from race gas, which has all the timing in it, and then we go to E85, which has all the timing in it, we gain power for the E85 all by itself. without just adjusting the timing to get the extra power. That's not part of it. The E85 adds power. So it artificially skews this relationship between the boosted combination and the NA combination, because you're not really getting much out of the NA stuff. Like if you were to when we put E85 in a 5.3 from a junkyard, it does nothing. It doesn't add any power at all. Partly because we're already, when we run these things on the engine dyno, they already have all the timing they can use. If we're running 29 or 30 degrees of total timing on a junkyard LS, there really just isn't any more left. Adding 30 or 31 or 32 or 35 or whatever number guys want to go to doesn't add any power. At least it doesn't when we're doing it on the engine dyno. But putting E85 in a boosted junkyard motor helps a lot. So these formulas and this discussion tells us, and we have a good comparison between two 500 plus horsepower motors as to find out which one of those is, because a lot of times guys will make comments on these videos when we run turbo things, whatever they are, any of the combinations. Well, you always talk about this power formula that you can double the power output at 14.7, but we want to see examples of when that actually happens. And these are perfect examples of not only did we do it, but we did more than that. These both exceeded this power boost formula, and for different reasons. The little Honda was run on race gas, whereas the 4200 was run on E85, and both of them managed to do better than the formula. Now, as I said, we could also do, and we ran ambient water through the intercoolers, the air to water intercoolers on both of these. If we were to do ice water, again, we would ice water. The gains seem to be kind of, on par with running E85, but when we're doing all this testing, there's some math that goes into it, as we saw from my board. And I go in the video, I go over all of that step by step. So you can see, and I did it at, as you saw on the board, I did it at different boost levels. So is it really efficient at 9 pounds and not as much in the case of the Honda, we went from 8 or 9 pounds all the way up to 24 pounds. So we got a big, we got a very good spread of boost to show the change so that we can apply this formula and we can find out how much power we're making per pound of boost and whether or not that changes as we go up in boost. Because the other thing that's going to happen is if that does change, if you start finding out that, hey, look, in the case of the Honda, we're making 13 or 14 horsepower per pound of boost because it's a relatively low NA power output. And that's what determines how much power you're going to make per pound of boost, way more than the turbo or the efficiency or any of that stuff. The NA motor that you're starting with is all but going to dictate how much power you make per pound of boost. So if you're doing very well at lower boost and then you start to do not as well at higher boost, there are several things to look at. In the case of the Honda, we were running a 57 millimeter turbo. So if we started to run out of flow from either side, either the compressor side or the turbine side, we could look at, hey, maybe we need to measure back pressure. Maybe there's a problem with too much back pressure. In the case of this Honda, that wasn't the case. There's more left. Is it an intercooler problem? Both. Are we getting boost stacking between the turbo and the intercooler? Is there not enough flow rate through the intercooler? Is there not enough cooling? Do we not have big enough cores? Do we not have enough flow of the transfer medium through here? In this case, it was water. There are a lot of things to look at. What about the exhaust after the turbo? Are we restricting that? Like if we find that we have back pressure, is it because we're restricting the exhaust going out of the turbo? Is the exhaust pipe too small coming out of the turbo? All of these things are things that you could look at, but you will only know if you know the NA power output and you know the formula and you know where it is relative to this formula. If you just know horsepower per pound of boost, and this is something that guys, I get these comments a lot and I get conversations with people a lot and they tell me, well, yeah, I know how well it's doing because I've never run the motor NA because we don't do that. We just run it turbocharged. So, but I ran it at 5 pounds and then I ran it at 10 pounds and it's making this much per pound of boost. I'm like, well, that's great. But the number that you started with at 5 pounds, let's say you're making 500 horsepower at 5 pounds of boost. Okay, is that good or bad? We don't know, because if your NA motor was already making 500 horsepower and it took five pounds of boost to make 500 horsepower turbocharged, it's not doing very well. On the other hand, on the other extreme hand, obviously in this example, if you had a 100 horsepower motor and you were making 500 horsepower at 5 pounds of boost, first of all, you're probably on another planet because that doesn't happen here. But you would be doing a lot better, obviously. And so one of those situations you're not doing well, and the other situation you are doing well, and you don't know. I mean, obviously, if you go from 5 pounds to 10 pounds and you can see, hey, like we're making 10 horsepower per pound of boost, or 20 or 30 or whatever the number is, it could give you an idea of what the NA power output is. And then also you can kind of use that to track if you see, like I talked about, okay, we're getting 25, 25, 20, 20, 18, 14, none. Okay, we're at the limit of something. And so you can find out that way. Just for me, I like to have the NA power output. I know, and the other reason that I do that is not just so that I can do this kind of, math, because everybody loves to play with math. I like to do it also when we run a motor. That way I know that the motor is right before we add the boost to it. I'll never be one of those guys that puts a brand new motor in a car and hooks the turbo up and does all that stuff without ever knowing that the motor itself was right before it went in there. I probably would never put a motor in a car unless I had run it on the dyno anyway. It tells me that, okay, that part of it's right. And if I'm having a problem, like what if we put it together and it starts misfiring? Okay, well, it wasn't doing that when it was NA. So now something changed. Now we have to look at the thing that we changed and solve the problem. If we didn't know that it was running good when it was NA, then all bets are off. Then we have to check everything. And that way, and the other thing that is nice about running it on the dyno or even running it on an engine stand is that you know that it doesn't leak. And especially if a guy's putting together a nice car, not like most of the ones that I have, they don't want obviously the thing leaking oil all over their driveways or all over the other parts in the car if it's all detailed and all that stuff. So it's a good idea to get them running and make boost. So that's my spiel, and I'll be loading that video up. So that's good stuff. It's good information for you guys, and you can apply it to lots of different stuff. Big block Chevys and small block Chevys, Hemis, everything. Every motor out there you can apply this information to. Somebody had a question on atomic MSD on a boosted LS3. Yes, you can run that. And I'm going to be running a boosted LS3 in the not too distant future here. We're going to make the Y pipe and a single turbo on it. And then I'm going back to see my good buddy Brian Tooley, and we're going to run it here because they have LT4 or LT5 injectors and pump and all that stuff. So we can get up at least fairly high in the power. Flex fuel LS engines are supposed to pick up 20 horsepower with the 85. You got to be careful when you're saying stuff like that, because that's not the same thing that I'm saying. Not that they don't pick up power, that they do pick up power. A lot of times on a chassis dyno, when you put other kinds of fuel like E85 in a car, it will show power gains. But it's only showing power gains because it adds timing. And we're already at the optimum timing level for the motor. So if we just change the fuel and have that same timing, and with no other change, we don't see a gain on the NA motors, especially a junkyard LS. And a lot of times we try adding more timing to see if it likes it, but it likes the same timing with the E85 and the 91 when it's that cold. 29 or 30 degrees of total timing, that's where those motors want to be, and that's where they run best. And if we try to add timing, it doesn't do anything, and then it starts taking away power. So on a chassis dyno where the thing is hot and it's in the car and all that stuff, and it's not running like optimized timing, maybe it's only running 24 degrees when it's running in the car on the chassis dyno. And then you put E85 in it, and then it goes up to 26 or 28 or whatever it wants to be at, whatever it will tolerate, and then you'll see more power. We've tried it on carbureted motors. We've tried it on all kinds of NA stuff. And other than the Coyote is the only thing that I can think that we've ever shown any kind of power gain with. A 100 horsepower engine supercharged on nitromethane could make 500 horsepower. Yes, but it probably will take more than 5 pounds of boost. I think it'll take more than that than the one I used in my example. What is the thumbnail picture of? It looks like a grade school kid put it together. Ouch, man, that hurts a little bit. We went all the way up to 5,500 RPM. That's where the VTEC change point. That one went to 80. I don't know, probably 8,500 or something. Yeah, ice water does skew the results, and so does E85, Tim. If you look at it, E85 throws it off as well. But if you run E85 or you run ice water and you don't get to the formula, then you really know that there's a problem. Running on pure oxygen would burn the heads. Yeah, that was my first question way back when I was in chemistry. When they were talking about it, they're like, yeah, we were talking about the piston engines in the war running nitrous oxide. And I'm like, okay, well, the only reason that it's working is because it's liberating the oxygen molecule. Well, why don't we just eliminate the middleman and just give it all the oxygen molecules? They're like, well, they tried that, and it was, I think his word was, it was very unstable. I ever messed around with a ZR1. The guys at West Tech have one, and I'm trying to convince them to run it. Kill is in the house. When is the new Maribera content? After I run the test. I ran my 302 on the stand and it twisted the oil pump. That happens when it's really, especially when it's really cold. 475 Cody turbo notchback. That sounds like a good combination. Please post your Gen 1 Turbo Coyote data when you can. The problem with the Gen 1 Turbo deal is that it didn't work very well. We didn't have very good control of the boost. So all we have is this big rising boost curve. So it's not really a very good test. I wonder if the 4200 with E85 would help. I doubt it. We can try it. I need to look back and see. We may have run the 4200 NA on E85. I'll have to go back and look. Would you ever consider doing a Volvo T5 Big Bang, pretty common junkyard engine? Sounds amazing and makes amazing power for their weight. A 5-cylinder would be cool. Do they have cams and things like that for that Volvo motor? You know, it's a turbo motor, so I'm like all in on that, right? What engine are you thinking about for the Nova now? All of them, really, right? I'm going to fall in love with either the 4200 for the Nova or the 3800 for the Nova. I consider nitrous oxide and oxygen-bearing fuels to be chemical supercharging. Yes, I'm that way with nitrous oxide, but not with like oxygenated fuels so much. I have a 6-liter LQ9 with a 7875. What is a safe power level I can run on the street? Do you have, the big question is always, do you have a couple of things? Do you have an intercooler? Do you have ring gap? Do you have good tune? All of those things will be necessary. That turbo will certainly support the power level that you're talking about. What kind of weird motor can I ask about today? Please let it be a Chevy Sprint motor. Mark, I did not get the file tune when I was down there. I can try to make a call. I think Ish can get it for me. I like when you put a spark to steel wool, and I like when you hook it to a string and then you spin it around in circles. At what point do you start gapping the rings? We gap them if I know that I'm going to run boosts. We've run motors at varying boost levels without doing that, but it's not a good idea because you just don't know what it is. Are there some membranes, presumably semi-permeable, that would passively separate oxygen-rich and nitrogen-rich air and use separate output streams? I think it would have to retain one of them, right? If it's a membrane. 100% O2 won't work. It supports combustion, but it doesn't burn. No, you can't run the motor just on oxygen. But if you have pure oxygen with all of those like power-giving oxygen molecules, and then you add fuel to it, just like you do with anything else, then you can get lots of power. Do you have to gap oil rings? I do not. I just make sure that there's enough. They're usually around 15 thousandths. You're ever going to do a Ford flathead? I'm never going to big bang a Ford flathead. I just don't see the point. And I probably will be running a flathead, but I think that the ones I was looking at were 4 cylinders though. How about running a 196 ICH 4-cylinder? It's half of a 392 V8. I know my new friend Jerry out not too far up the road from me. You saw a couple of videos that I did. He has the 2JZ in the AMC. He has the AMC 6-cylinder that came out of there. And presumably I could run that because I think it's a running motor. So somebody let me know. I don't know if I think it has the transmission that goes with that too. I have not run nitromethane in anything. Let's see, as a rule of thumb, our general guideline for sizing BOVs and wastegates. Wastegate is usually turbo and power output. This may seem odd, but it's harder to control the thing at lower boost than because it has to wastegate more exhaust out. It's harder to control it at lower boost than it is at higher boost. So if you're looking for a big, broad range, it gets more difficult. We run 2 on the dyno, and you should be looking at something that's 45 to 60 millimeter range. Bought a GT45 for my 5.3. What would you recommend? Like I said, we run 45s. I think a single 45 would do it. You know, if you have room, usually that's a fitment problem. You could get something bigger than that. And an S480 would be fine on your 5.3 if you want to make into the 4-digit power level range. You should put the 4200 in the Mustang and the Barra in the Nova. Yeah, I think that the Barra would go in the Mustang. I think that would kind of be cool. The 292 is still going back together. You need to get that 3800 out of your system. I can't. There's no way I can. I promised that I was going to do a big bang on it, and I am. And I also want to run it. I want to run it because it has a blower on it already, and then it also has an exhaust that just screams out, I need to have a turbo on here. So, I mean, how can I ignore that? You can't, because then you can run a turbo into the blower, which I definitely plan on doing. Yeah, the 4200 in the Nova would be kind of cool. That would be a very good 6-cylinder in that thing. The Ford Focus RS non-US used a Volvo 5-cylinder was 335. There should be cams. Okay. Bruiser, my buddy and I have a bet. I like the sound of this already. On an LQ4 6-liter with a sloppy stage 2 with milled 317 heads, make more power than stock. The same motor with 862s. If all you're doing is a milled 317 versus an 862 head, I honestly don't know. I don't know how much you can take off of the 317. The 317 doesn't have a good chamber. It's not only big, it's just not very efficient. So even though everyone wants them to flow a lot, this flows the same as a 243, that's not what's going to determine how much power you're going to make. The sloppy stage 2 is not an ideal cam for that either. But looking at the results that I got from the 317 862 head test on a 6-liter, I think it's going to be hard for the 317, the milled 317, to make that power up. I've never even run a 409, let alone boosted one. I've only ever seen, the guys at West Tech, I think, have run one there. And I did see a 348 at the wrecking yard, but a guy had already got it, and he got the transmission. Yes, a pair of 6.5 liter diesel turbos would be, from the mid-90s, would be enough for a 350 Chevy. Happy to help, Mark. Richard, have you ever seen Cody's Labs videos where he burns oxygen in a propane atmosphere? No, I haven't. It's mesmerizing. It sounds like it. Or if they're readily available aluminum heads for the 3800. I do too. And there's so many of them out there. There's so many of them around. How long will my 60E last on my Turbo Silverado, making 600 horsepower to the wheels? I think it's done. I think it's broke. Yeah, that's what Cole said. The nitrogen is a buffer to slow and control the combustion process. Pure oxygen and fuel would be a bomb. That's what my chemistry teacher meant by it was volatile. Yeah, you got a big change in the heads going from, I mean, it's 10 cc's, so it's a lot. The Nova does seem right for the inline six. I mean, that's what came out of it, and all of those inline six cylinders, and they're all awesome. The 230, 250, the 292. They're just. I know guys in Brazil or wherever are doing crazy stuff with them, but the cylinder heads that are on those things are just not great. I've seen the Gale Bank stuff. His turbo and supercharger stuff on diesel engines honestly doesn't interest me that much. I just am not real heavily into diesel stuff. Have you actually tested the coefficient of discharge, or just a theory thing? Yes, we have. And when I have Brian Tooley on, we can go into detail on that. Have you seen Micro Machine videos of the young man hand building Boattail Speedster? That's kind of cool. International Harvester, that is cool. Yeah, the Barra's not. I think that both the Barra and the 4200, like the Barra in the Fox and the 4200 in the Nova, is probably going to be hood scoop material, I would think. At least a cowl hood, 69 Z28 kind of hood. Mark's out. What are your thoughts, Richard? What are your thoughts on a 40 over 6 liter with an LS3 camshaft and an 823 heads? That's going to be like a 40 over, the equivalent of a 40 over LY6. And if you look up on my videos, I have an LY6 that we ran with the LS3 cam and those rec port heads, so you can see exactly what it does. Dragon, I did get the 2.2 turbo. I have videos up, and I've posted stuff on Instagram and stuff about it too. So I have it here at my house. Richard, when I assembled my motor, it was in the middle of the winter, then drove it to California. My question is, do I need to redo the time out here? You mean, are you talking about the break-in? If you drove it out to California, where did you drive it from? Just wanted to say hi, enjoy all the information, happy to help. Thank you, Corn-Fed. I drove a Pontiac G6 last weekend with a 3900. It had the dual runner intake. That sounds very cool. Nice mid-range and revved to 6,000. All the way up to 6,000. Are you listening, Flex? Did you hear that? It went all the way to 6,000. What about using nitrous in a turbo engine after the intercooler? We've done that a lot. It works very well. We've used it as the intercooler in place of the intercooler, which doesn't work as well, but we've also used it after the intercooler, and it works very well. We also used it with blowers. Again, all of that's good. Nitrous always works like nitrous is supposed to. On the turbo stuff, it can make the boost go up too if you don't have total control of it. An idea for the most efficient supercharger, a variable ratio centrifugal supercharger, but also linked to an exhaust-driven turbine via freewheel, basically part turbo, and with a mixed flow compressor. Okay, so just design that and then manufacture it and then test it and then come back on here and then let us know how it did, because that would be awesome. Ryan, I said this before, but I'll be tempted to use the Dart Big Block Chevy tunnel ram intake if I build a custom ram air lid facing the rear for my twin turbo setup. That would work. Yeah, Mike, I had heard that a lot of the production engines were fired up on LPG, that it's just easier for them to basically cap the deal on there and start the motors up and run to make sure that they run and that they have oil pressure and all that stuff. We could just run liquid oxygen and liquid hydrogen in a tube and make it a rocket. Now that's just crazy talk. What are your thoughts on a ported factory 351 EFI upper and lower on a turbo 408? Are you talking about the factory truck manifolds? It's going to be problematic to hook them up to the dual throttle body that they have. It's not ideal because it's designed for low RPM and it doesn't flow very well. And you can extrude hone it because they're fairly long runners. There are better choices, and especially on a 408, it's going to want to make power really at a really low RPM. But with boosts, you'll make power. Cast iron LS heads. I've actually never tested any. I've only ever had one set, and they weren't even mine. They actually belonged to Chad Reynolds, and they came off of his motor from his Suburban, which became the Big Bang Gen 3 6-liter, the first one that I tested. That one made 1,482 horsepower, like 28 pounds, and we took those iron heads off. And I don't know if I ran that motor stock or not. I'd have to go back and look. I'm told that they make the same power as a typical 317 head, but I haven't. Unless I ran this one when we took it out of his vehicle and just put it up on the dyno and ran it. Unless I did that before we tore it apart and did stuff to it, and that would be odd because I do like to find out and make sure the thing is working before we put all the effort into it. John, what was your question? John's from Ohio. I did break in there, so I was talking about timing and air temperature. So I didn't see your other question, John. So let's see. Oh,
Assembled by motorists in the middle of winter and then drove to California. My question is,
if it was very cold when you did it, it might have a little more timing than it would want during the summer, and especially if it's carbureted, it might have not exactly the right amount of fuel. It's going to want less fuel. If it's hot, so if it's EFI, that can be tuned, or at part throttle and stuff, it could self-tune at least the air fuel part of it. But you might want to look at the timing. I've seen Casey. I've seen like rolling roads and stuff that they use for race teams, Formula One, and those guys. Well, they can simulate everything basically on the car, and that's pretty cool. I haven't seen the Porsche deal though. I don't have a 7.3 Godzilla, although Mahovitz had one that he said we might be able to use. I don't know about the diesel. It's going to change the air fuel, and it's going to be awful. I don't know what the flash point is. The lump port heads for the 292 flow pretty well. They flow, what you mean is they flow relatively well compared to what they flowed before you did that modification to them. But they're still not great. Troy owes you a steak. Did you guys race? How bad do you think a 4.8 LS would be choked by a set of TEA stage 3 ported 241s? I don't think it would be choked at all. I mean, I've seen those things go, 310 or 320, I think. If that's the same program that they use for the 706 heads and for the 243 heads. Mike's here. Yeah, the truck intake is not going to be ideal on that 408 Ford, but, with boost, it will work. A stock 4.8 revs well beyond 6,200. How about I send you the set I have? Gearhead, what did you have that you were talking about? If they're iron LS heads, I'm not I'm not really interested. Is the LF1 the V6? Brandon, what we used on my brother's Omni, we snagged a 2.5 out of LeBaron, stuck the 2.2 bathtub head on it with a Super 60. We used a 3.3 throttle body. All of that stuff is pretty standard stuff. Did you run an intercooler on it also? Yeah, the tilt rigs are kind of cool, Andy. I like when they do the simulation, because they can't, other than taking it out on their proving ground, which they have, and they do that kind of testing. But it's just easier if they can do it, in the laboratory environment, and having that rig where they can simulate LS. Because as we know, a lot of these LS motors had oiling problems. I have a junkyard Elm 7 with a stage 2 truck cam using a 92mm throttle body. Will throttle body hurt performance? Is it too big? There's no such thing as too big of a throttle body. A bigger throttle body will never hurt you. The only thing that it would ever do is make it maybe too responsive when you're just opening it up. So sometimes tuning is necessary, especially on a drive-by wire thing, and especially if you put a big throttle body in front of a positive displacement blower. But for your application, it won't do anything. Uh-oh, Turbo 32. Why are you asking me about timing? You already know. Can you recommend the maximum ignition timing for a Turbo 464 valve on pump gas? Nope. Pass. You're running 18 degrees at 1.7 bar. That already seems like a lot to me on pump gas, unless it's pump E85. I have a stock 5.4 3-valve with a phaser tick. Thinking of getting out of its misery with an EB turbo. I can get the manifolds off. I have some 3-valve turbo stuff that we've done and blower stuff, but they were all 4.6s and not 5.4s. Why are you guys talking about trying to just run an engine on hydrogen peroxide? Why do you care about that? What are your thoughts on anyone that wants to build a low boost application on a stock ECU? The stock ECU works fine. As if you take a look at what Matt has done over on Sloppy, which he does great stuff, he runs a lot of stock ECU stuff, and he's really, really good at that. And so you can run lots of boost on those, and especially a low boost thing would be no problem at all. Running a 2.2 stock bottom end behind a 5-speed with a forward motion enforcer 2 turbo injectors, map, Indy Super 60, intercooler. Okay, 3-inch exhaust. Makes over 300 at the tire. Nice. And what did you say? How much boost was that, though? What boost level is that? Is it 20-something pounds or something? A 4G63 turbo Big Bang would beat all Hondas. So are you talking about the Eclipse motor or the Evo motor? I think you missed my message. I didn't miss your message. I asked you if the LF1 was a. I thought it was the newer V6, but that's an LV3 or something. What year is that, and what car did it come from? 20 degrees out. Yeah, that's the motor feels really good when it's 20 degrees outside, I bet. Tom's in the house. The LF1 you think is better than the 4200? Okay. What are your thoughts on the Sniper X-Ram intake with dual throttle bodies for use in a twin turbo application? I think the thing that holds the Sniper back is the dual throttle bodies. I think people have trouble making 2 throttle bodies work. If you can do that, then the manifold itself is good. As long as it fits in the area where you're trying to put it. The power curve is really nice. It's one of the few manifolds that makes more low-speed power than the factory truck or the Trailblazer SS manifold. It also makes more top end. And it looks cool if you had two, one turbo on each side feeding them, obviously through an intercooler, because you want to run an intercooler on everything. Otherwise, it works very well. If you take a look at the video I have up, you can see I ran a test on it, and it makes good power. And as we all know now, because it makes good power NA, it also makes good power under boost. You rocking it out, you ran 26 pounds on 93 octane. What did you run? Like negative timing on it? There's not a way to tell if an engine will break by how high you can rev it, what the safe amount is. You can use experience, and you can go online, and if you have a small block Chevy and you're trying to rev it to 12,000 RPM, everyone will tell you that won't work, and so you should use that information. And you should be able to feel, if you're a driver, you should be able to feel the power curve of the motor. You should know when it starts to fall off, or just take it to a chassis dyno. That's fairly quick. Yes, the Cobra R stuff is really kind of nice looking. Those intake manifolds are. And all of the Australian ones, like the Boss manifolds that they have over there for the modular program, are really nice. Log manifolds versus headers and turbo use. I'm going to try to do that on this 2.2 liter, because everyone is saying, all of the stuff that I've read, and I know that a lot of the stuff is really old, but they're saying, oh, there's no benefit to a tubular manifold versus these big, log manifolds or whatever. So I'm going to try to run that test. I want a turbo, a 2JZGE, a GS300, okay, eBay GT35, okay, so that's like a 500 to 600 horsepower turbo, 6-pound spring, stock injectors, stock ECU. I think you need to find out what the stock injectors flow on that with an FPR fuel return on a MAF. I don't think all of that's going to work. You're going to need to tune that. Have you ever boosted a 2V 5.4 mod? No, I haven't. We've done 5.4 4-valve motors, but not the 2V stuff. I've done lots of 2V 4.6, but not 5.4 stuff. On my 327 with AFR 134 heads, so I'm thinking that might be 185. Monic Shop is making me run a stock 350 intake. Truck hasn't been fired today, but what type of performance do you expect from that combination? I don't know what cam you have. I don't know what headers you have. I don't know any of that stuff. The heads are really good. The stock intake actually works fairly well. It'll have really good low speed response if it's a 4-barrel intake manifold and is a I hope it's not a tune port. No, if it's a 327, it's not. Then if it's a stock 4-barrel like Quadrajet manifold, or even a Holley manifold, because they had stock ones for 327s back then also that accepted a Holley, those actually work fairly well. They don't work as good as an RPM air gap is, but they're not terrible. Could we get a test of a tri-Y stall turbo header 2? Recently heard 2 different guys that switched to tri-Ys and picked up a little horsepower per pound. Three-bar map, 80-pound injectors. Timing curve is similar to a Super 60 style curve built by Mopar Performance. It does have a forward motion 505 cam. 12-to-1 air fuel. That's 12-to-1 air fuel with 93 octane. That's pretty spicy. 1500 EGTs. The EGT is a function of the timing. I don't know what that timing is, but I don't run a lot. I don't run anything ever at 26 pounds on pump gas on 93 octane. So kudos to you if you got that done. Big Bang Toyota, that would be good.
Max power stock block 6 liter. I probably won't go 3.9 or 4-inch stroke. It will keep the head gasket in longer. Why not? Could you tell? I won't do self-learning stuff on a turbo motor anymore. I did that once and I won't do it anymore. Any chance of a Jeep Dodge 4.7 single overhead cam V8? That's not on the list, but you know, I get a lot of people ask about that motor though. Can you get individual throttle bodies on a 4200? If somebody made them, we certainly could. I think we all feel the same way about the RPM Act. I think we all feel the same way about the EPA trying to control that. The RPM Act is not what that's called. The RPM Act are the people that are trying to counteract that. Oh, the model number is 134. Okay. Comp 4x4 cam. Five minutes left. Yeah, it'd be hard to find that DFA. It'd be hard to find a Z28 4-barrel manifold. But even if it was a 327, it could have come with the L79, which would have been the 350 horse 327. That would have been an aluminum manifold too for a Holly, a small one though. What is the relationship between EGT and timing? If you lower the timing, the EGTs typically go up because you're getting burned out in the exhaust. It's happening later, basically. How do you define trick air intake? I don't know what the question is. An air intake should be a cold air intake. Is that trick enough for you? Oh, they won't. It came stock in a 76 K5 Blazer. So that's going to be a cast iron quadra-jet if it is a 4-barrel though. What is a safe boost level for twin TO4 e-turbos with a 350? That's the wrong question. The question is, what's the safe boost level for the octane that I have, and for the tune that I have, and for the fuel pump that I have, and the carburetor or injectors that I have, and for the intercooler that I have? That's more appropriate. The 350 Chevy you can make a lot of power with those. Fox Body 302 small turbo setup, low boost, aftermarket heads and cam. Is an aftermarket intake suggested, or is a port match stock intake good enough? All of that will work. The factory HO intake is definitely going to hold you back. It's going to want to make power at a very low engine speed, and it also doesn't flow very well. So with any kind of intake, a GT40, a trick flow, you're going to pick up, I don't know, 25 or 30 horsepower, maybe more if you already have the heads and camshaft. And then when you add boost, you're going to be multiplying that. You won't be able to run, you won't run closed loop at wide open throttle. And so if they're 220cc injectors, they're going to be sized for the stock power output. And if you're increasing that by 50%, the injectors probably don't have 50%. And it's actually going to be more than that, because it's not going to be 50% NA. It's going to be 50% under boost, which is going to be more like 70 or 80% increase in fuel. You need bigger injectors, and it needs to be tuned.
The only other way to get away from that is if you put an FMU on it and it has a rising, and basically it closes the fuel return line down and raises the fuel pressure. That's another way you can get away with that. But the other thing is you need to have less timing with your turbo setup than you have with your NA setup. So you have to have a way to pull timing out. If you try to run factory timing with a turbo, you're going to blow the motor up. I do want to do a fuel cooling test. I do want to do a J Series Honda V6. That motor is definitely on the list. And I look at those every time I go over to the wrecking yard. I just have to stop getting motors. I have to do the ones that I have and then just assume that the other things will be there. Now, the 2.2 Chrysler was the exception to that because that's the first one I've seen in years, in a decade, I'm sure. Have you ever tested a step-down intercooler piping to maintain air velocity? I don't think you need to do that. I don't think you have to worry about that. You don't need to worry about velocity. I want to see a GM high-feature V6. Well, now you just get together with Tim. He wants to see one of those too. I feel like it's had to be done the 4.6. I have done a 4.3 liter V6, but one of the new ones is going to be good. And I'm going to do one of the new ones, one of the LT1 based 4.3 liters, because we're going to do that with the guys at Brian Tooley. And we can do variable cam timing and all kinds of cool stuff. TrickFlow Intake is, TrickFlow Specialties is the name of the company. They make different intake manifolds. Big Bang 90s Lexus V8, that's a Toyota. I tried fuel cooling. It made very little difference. The guys at Engine Masters got gains from it. The stock VVTi timing adjusts a lot, and not just the cam timing. The ignition timing is what you're worried about. The variable cam timing at low boost, I'm not too concerned with. I am worried about ignition timing though. Richard, did you ever use something like a 30-pound or 24-pound mass air sensor for a Ford with an A9L computer? We did. I didn't have an A9L till way later because my factory computer in my 88 mass air California only car was different than that. But I did use, I had a 24-pound meter at a 30, and then ultimately the one we put on there was a 36-pound meter, which I still have, and I call that my, this has been decades now, I call that my magic mass air meter because it worked awesome. And I even used that mass air meter with those injectors on a Ford Focus also. We just tried it and see if it would work, and it did. My tuner, I wanted to test how much the air is cooled right behind the valve. So are you testing it with gas or E85 or intercooling, or what is it? It would be hard to get a fast enough reacting temperature probe in that position. That's kind of the difficulty with that. I think what they did was carbureted when Engine Masters did it. Joel, if you've got a 6-liter LQ4, then just keep the stock truck intake manifold. Works really good. The J series I like because I've seen lots of those with the guys at Westech. The chassis dynos and Ish have done, especially back in the day, lots of sand rails that have had that motor, and guys are just putting turbos on those motors and running them, and they work really well. Yeah, Risen, you're going to try E85. That's the thing. E85 it's going to help, and you do get power from E85. I just don't know how much charge cooling you get if you're injecting it right at the port. There just isn't time when you think about how fast all of this stuff is happening. Do the calculations on how much one cycle is, and so how much time that has to cool that charge of air that goes in, because after that charge of air goes in, then another one has to go in. So another heated one has to go in. So there's not a lot of time for that charge cooling to actually take place. There is if it gets injected a lot earlier in the cycle, and you get to have the charge cooling take over time because it travels more distance, then it works fairly well. The 85 works and it does get good power. I just don't know as a port injection thing if you're going to get much charge cooling going on. But there would have to be a way to measure it, and we don't have the ability to do that. I saw that the Motor Trend guys had killed all of the stuff outside of North America. Kennedy, does rod ratio matter? I haven't seen actual back-to-back dyno testing where it shows me that it does. Water meth will definitely cool the EGTs. What boost level do you think is safe for non-intercooled with the 85? Whatever doesn't make it detonate. And I don't know what that is, because there's a lot of other things that go in with that. It's not a boost level versus the 85. It's what is the detonation threshold of your combination, and then there's like 8 other things that are going to affect that are not the fuel. So did you soften the chambers, the compression? What is the air temperature you have going into the turbo? Are you silly and drawing air from right behind the radiator where it's 200 degrees going into the turbo? Sadly enough, lots of guys do that. So there's a lot of things that go into that question. Darren Morgan tried all kinds of different rod ratios and came to the conclusion that all you need to do is connect the crank to the piston. I read lots of guys, Smokey Unick and these guys, that talked about that, and a lot of them came to that conclusion. They said you need the piston going up and down. That's what you need, and it has to have to have something that connects that piston to the crankshaft, and so that's called a connecting rod. I know people want to talk about dwell time and all these different things, but I just want to see it in real life. I want to see it on the dyno, just like I want to do the piston flipping thing, and I want to see it do it so that I can then refer to it. I don't know how you control timing on the factory ECUs. I don't know if there's a way to get into those factory 2JZ GE. That's from a 300, I think. I don't know how to get into those ECUs. I'm not familiar with those. What about running turbo at the factory 58 PSI through boost level tuning? I don't understand the question, John. I found you in here by the 46 PI. I just got a 99 F150. Want more information on it? Take a look at the videos that I have up on the 462 valve stuff. There's lots of camshafts and cylinder head testing and blowers and turbos and all kinds of stuff. John, thank you, John. But what was your question, though? What did I not understand? Nitrous jet before the intercooler, so everything freezes.
E6 heads are easily the best cast iron head ever made. Are Teflon piston rings viable? I've never even heard of that. Kennedy, are you asking what the stroke is on a 6-liter LS? 3.622 is like the 5.3 and the 6.2. Sweden's in the house. Have I ever tested a liver noise ported 243s? No, and this will be the last question, but I have tested lots and lots of 243s, and there's lots of good programs out there, and by now people have figured out how to make a 243 head if they've really put the work into it with bigger valves and stuff. Those things can flow 310 or 320 at 600 valve lift. So there's lots of good heads out there, and if you take a look at the head video that I have on the LS stuff, I think that they were all covered by about 10 or 15 horsepower, the best and the worst stuff. So there's lots of good ways to make power. They probably know what they're doing. I'm sure that they've done their homework. Kennedy, most guys with a 6-liter go with a 4-inch stroke. Tips on injector fuel pump sizing for twin turbo 6-liter LS 15 PSI stock everything. So why did you decide on the 15 pounds on stock everything? You're going to run 15 pounds on a stock cam and everything? The springs might cause you problems, and you're going to need like 1,000 horsepower worth of injector. So if you're going to run E85, that's going to mean 1,000 cc's. The turbo for the 4200, like the max speeding guys, have a GT3582, which should probably work pretty well at the 500 horsepower level. Thanks, guys, for showing up. As always, I got to get this video up because it's almost done. Got to do the turbo mass stuff with a B16 turbo and a 4200. Thanks, guys. I will see you tomorrow.